Okay, now we're doing question number 6. In this question, we are asked to determine whether a crown is made of gold or not. Okay, in the first case, the crown was weighed in air, and you can see from the picture here. When the crown is weighed in air, the reading of the balance was 7.84 newtons. Right, so if you were to draw a free body diagram for the crown, it will look like this. Right, so the forces acting on the crown would be the weight and the tension, or rather the force exerted by this string on the crown. Right, and of course this tension is related directly to the reading of the scale balance, right, of the spring balance, because it is what is causing it to give the reading, right? Okay, so this tension here will be the same as the reading of the balance, right? Okay, so it's obvious that the crown is in equilibrium because it's not moving, therefore it is in equilibrium. So net vertical force must be 0. So T minus W must be 0. So T is 7.84, right? So that gives us W. Alright, and W is, of course, it goes to the weight of the crown, which is mass times acceleration due to gravity, and this allows us to find the mass of the crown to be 0.799 kilograms. Okay, now we look at the second situation. Right, in the second situation, the same setup is used, but now the crown is fully immersed in water. Right, so you find that the reading of the balance decreases to 6.86 newtons. Right, so if you were to draw a free body diagram for the crown again, right, it will now look like this. Right, so the forces on the crown will be these three forces. Of course, the weight of the crown hasn't changed. Right, so you notice that the same force vector, the same arrow is drawn here as is drawn here, right? It's because it hasn't changed, right? However, there's now an up thrust on the crown, a buoyancy force exerted by the water, right? So I use a green arrow, right, to represent this up thrust, and as a result, the tension in the string, right, has now lessened from T 7.4 to T prime 6.86 newtons, right? And of course I use a different letter, right, to represent this new tension. Okay, but again the crown is in equilibrium because again it is not moving, right? So again, for equilibrium, right, we are talking about this second case now, right? So it's in equilibrium. So again, net vertical force is 0. So the two upwards forces balance the one downward force, right? So T prime is 6.6. U we do not know, but W is the same as before, right? 7.4. So 6.6. Right? So this allows us to find the up thrust. Okay, by Archimedes' principle, this up thrust is equals to the weight of the water displaced by the crown, right? And the weight of the water displaced by the crown is simply the volume of the crown multiplied by the density of water, right? So volume of crown times density of water gives you the mass of the water displaced by the crown, and this mass of the water displaced by crown multiplied by G gives you the weight of water displaced by the crown. So this expression gives us the up thrust. Okay, we have already found the up thrust to be 0.98 newtons, so 0.98 newtons will be equals to volume times density of water times G. So this gives us the volume of the crown. Okay, so in summary, we now have the mass of the crown and the volume of the crown. So obviously that allows us to find the density of the metal used to make the crown. So density is mass over volume, so that allows us to calculate the density of the metal used for the crown to be 8,000 kilogram per meter cube, which is less than the 19,300 kilograms per meter cube of gold, right? So the crown is not made of gold. Okay, so that's the conclusion.